Et maintenant avec vous, Jean-Michel Desobeaux qui vous parle en direct depuis le bâtiment Jupiter sur le sport spatial européen. Bonjour à vous tous qui suivez cette vidéotransmission en français depuis Kourou ou ailleurs en Guyane ou bien en métropole à Évry, Paris, Arvers ou Saint-Germain. Ou encore via notre site internet www.arianespace.com. Comme vous le voyez à l'écran sur votre droite, notre Ariane 5 de ce soir, une Ariane 5 ECA, avec ses deux passagers Spainsat et Hotbird, qui est dans la phase finale de préparation au lancement. Tous les étages sont remplis. Et comme Jean-Yves Le Gall l'indiquait à l'instant, les derniers contrôles sont en train de s'effectuer pour donner le feu vert du démarrage de la séquence finale lanceur qui va démarrer à -12. Mais tant que ces contrôles ne sont pas complètement terminés, l'ensemble de lancement, le compte-rendu ensemble de lancement que vous voyez à gauche de votre écran reste au rouge. Et la synthèse que vous voyez en haut à droite derrière le décompte reste elle aussi au rouge. Pour mieux comprendre ce qui se passe en ce moment, permettez-moi de vous dire quelques mots sur ces remplissages cryotechniques en hydrogène liquide et oxygène liquide. Ce lanceur Ariane 5 ECA a deux étages qui utilisent ces ergols cryotechniques. Le premier étage, le plus bas qu'on voit en ce moment défiler sous la caméra, le PC, et l'étage supérieur cryotechnique. Ces remplissages en ergols très froids sont très délicats à mettre en œuvre depuis les réservoirs de stockage de ces ergols qui sont à quelques centaines de mètres du lanceur et le lanceur. Et pour effectuer ces remplissages, il faut d'abord progressivement mettre en froid les lignes sol, puis les lignes bord, puis les réservoirs. Et très doucement commencer à remplir les réservoirs en ergol, donc en hydrogène liquide, en oxygène liquide. Pour donner une petite image, il faudrait essayer d'imaginer de remplir un réservoir chauffé au rouge avec du champagne. Ça vous donnera une petite idée de la délicatesse de ce procédé, de d'abord mettre en froid, refroidir le réservoir, puis remplir tout doucement. Maintenant, ces remplissages sont terminés et les équipes au centre de lancement à quelques 2 km du lanceur sont en train d'effectuer les derniers contrôles techniques suite aux petites anomalies qu'on a rencontrées il y a 2 jours, le lanceur étant maintenant complètement rempli. Et ce sont eux qui referont passer le compte-rendu.
Whereabouts and if we can describe them on the launcher, we can see it on the screen. I think we have can see the solid boosters at the side. Would you like to say a few words about the structure of the of the vehicle?
Well, yes, you can see on the screen then the two boosters which are attached to the main cryogenic stage. These boosters are manufactured in French Guiana for the two lower parts of the boosters. And the upper segment, the upper part of the boosters are manufactured in Italy and then brought to French Guiana. And the whole integration is made here in Kourou.
Right. Well, while Alex was talking, we had a look at the top of the launcher, the fairing, and we're soon going to show you a film about the fairing, so that you can see the components and what goes into making it.
Mating the upper satellite plus Silda in the fairing on top of the inner satellite on the launcher is the last mechanical operation before transfer of Ariane to the launch pad. The fairing has a diameter of 5.4 meters and is made of two halves connected by pins. It may be delivered in three lengths: short, medium, and long. The Ariane fairing is manufactured in Switzerland by Contraves. The various panels for half fairings are prepared in Contraves premises. These panels are made of a sandwich of internal carbon skin, aluminium honeycomb, and external skin including the thermal cork-like protection. These individual components are then moved to Emmen at Ariane Aerospace to be integrated on the assembly station under Contraves oversight. At last, special white paint is sprayed to protect the fairing against electrostatic buildup. During the assembly, complete controls are performed on the structure itself, but also on the pyro and electrical systems. The acceptance of each fairing is pending upon their result. Scale 1 separation tests were run at the NASA John Glenn Space Center. They allowed to perform separations in vacuum with conditions very close to the real space environment. Once accepted, the fairing halves are barged from Bow to Rotterdam before being shipped to French Guiana. In Kourou, the Contraves team integrates the fairing around the upper spacecraft, and the Silda then made the assembly on top of the launcher. The fairing has several functions. First, during the waiting time on the launch pad, it protects the satellite from rain, heat, humidity, and from any pollution. Kept in clean environment, the satellites are comfortably air-conditioned. At liftoff and early flight phase, the fairing protects the satellites against the acoustic vibration created by the very hot gases of the Vulcan 2 and strap-on boosters. During the later flight phase, the fairing shields the satellite from the aerothermal friction when slicing through the dense layer of the atmosphere. On the early Ariane 5 fairing, acoustic protection was ensured using complex Helmholtz resonators, including in an aluminium alveolar structure. Recently, optimization studies allow to improve the mass efficiency ratio. As said Mr. Bonham, we are inside one of the latest Ariane 5 fairing equipped with the new acoustic protection. This system was flight qualified during Flight 164. It's made of new absorbing pad, made of a high-tech foam, sealed with a tight sheet for cleanliness purposes. Earlier, there were sound absorber in aluminum on pads, which have been simplified to get cheaper, lighter, and simpler options. Here we have the initiating system to split the fairing. Two detonators are installed to trigger the fairing separation. We see also the measurement sensors, which confirm the separation, the distancing, as well as the breathing of each fairing half.
Un système aussi qui permet de mesurer la respiration de la coiffe, toujours après la séparation de la coiffe.
Also seen is the long zip line for telemetry transmission during separation. This line will unwind over around 10 meters to transmit data during 1 second, and it will be pulled by this metallic cable. Contraves built its first Ariane fairing for the Ariane 1, which lifted off on December 24, 1979. Contraves is right now developing the fairing for the new European Vega launcher on behalf of ELV. For more than 25 years, Contraves has been a major partner of Arianespace.
Well, that was an interesting introduction to the top part of the launcher. Before the film started, we were talking about the various propulsion systems. We'd talked about the solid boosters. Starting again nearer the bottom, the Vulcan engine and the first stage, Alex.
Yeah,
Tell us
so
about that.
the first stage is the one that was also designed
À
for
tous le
the...
DDO, retour au vert de l'ensemble de lancement. Tenez-vous prêt pour une reprise du temps des comptes.
So the DDO calls out for the resuming the operations and
Attention pour reprise
starting...
du temps des comptes. Top, reprise du temps des comptes, début de la séquence finale lanceur.
There we are.
Right, so we started
Le
the
nouveau
count again.
H0 est 22 heures, 20 minutes et 21 secondes en temps universel.
So we are back to greens, and we're progressing through the countdown now. But perhaps we can just continue a little bit about what we're talking about, the propulsion.
Yeah, so the ECA is equipped with the Vulcan 2 engine, which is the most powerful than the Vulcan 1, which equipped the generic. And on top of that, we have the upper cryogenic stage, which is equipped with the Ariane 4 cryogenic engine, HM7B.
Right,
But has a totally new design propellant tanks.
Right, an interesting heritage that has come from the previous generation, but further development. Now, the payload, the satellites, are mounted, as we saw, at the top of the launcher, and they are enclosed. The fairing protects them from thermic reaction throughout the atmosphere, but also there's another container for the one of the satellites called the Silda.
Well, the Silda is a carrying structure, which allows the upper satellite to be mounted on top of the lower satellite. So it's inside the fairing itself. It's mounted on the VEB upper flange.
À tous de DDO, rouge lanceur, on va arrêter le temps des comptes.
The DDO called out for stop of the synchronous sequence. This thread is coming from the launch base, from the launcher. So we'll wait until we get some more information about this thread and when we can restart the synchronous sequence.
Which will reset to 12 again.
Which will be reset to 12 again to start all over again all the processes that will finally allow the H0.
À tous de DDO, moins 12 minutes réaffichées. Tenez-vous prêt pour une reprise du temps des comptes.
So here again, the DDO asks everybody to be ready to resume at H0 minus 12 minutes.
Okay, and while we're waiting, we'll continue with our description of the launcher. You mentioned the vehicle equipment bay just now. That's where the onboard computer is located.
Well, not only the onboard computer, but also the brains of the launch vehicle. So the navigation system, the inertial platforms, and all the electrical equipment, which such that telemetry equipment, telemetry terminals, and so on.
Right, and that vehicle equipment bay is the part just below the payload area.
Well, yes, it's just between the upper cryogenic stage, and the fairing and the satellites.
So there are many components of the Ariane 5, and they're all manufactured in Europe by a number of companies.
Well, yes, the boosters, I said, are manufactured here in Kourou. The upper parts of the boosters in Italy, the fairing in Switzerland, the upper cryogenic stage in Germany.
Right, so they're all shipped in before launch and assembled here in CSG.
They're all shipped by boat. The boat is going from Le Havre to Kourou Harbor. Then everything is unloaded from the boat and transported by truck to the CSG, to the launch base. So all these elements take the boat. Everything is collected by the same boat, either Germany or France, and then goes to Kourou.
But normally the satellites come in by air transport.
Well, yes, usually the satellites come in by air transportation, yes.
Right. And it's all here, and everything is assembled in the I think 58-meter tall launcher integration building.
Well, we have two buildings. In fact, and one is the integration building, for which we have all the assembly of the launcher, except all what concern the satellites. I mean the fairing and the cylinder and so on. And the second building, we make the final assembly, where we have the integration of the satellites and the fairing on top of the launch vehicle.
Right, and we are now going to show you a film on the protection of the environment.
And we'll be right back.
Here's a riddle for you. What looks like a boat, but runs on rails? The answer, the Ariane 5 launch table. This second Ariane 5 launch table was first used back in November of 2000. That was for Flight 135. At that time, the launcher for 135 was one of 4 launcher campaigns going on here at the CSG at once. That was a first. So you see, having the second launch table makes a big difference. It means we can work on 2 Ariane 5 campaigns at the same time. With us is Martin Unal, who's Ariane's launch operations deputy, and Martin's going to tell us more. Martin, what's the role of the launch table?
The role of the Ariane 5 launch table is to provide the launcher with everything it needs to be ready for launch. It provides propellant for the main stages, electric power for all onboard electronics, and diverse tracking, telemetry and command which let us carry out all operations. Let's go inside and have a look. In this part of the Ariane 5 launch table, we receive the customer base, which let them monitor their satellites during launch operations. The satellites are pulled through this trapdoor in the floor by a crane, and we secure them on the ceiling with heavy springs which absorb the vibrations at liftoff. From here, customers can connect to their satellites via dedicated links installed by Arianespace on board the launcher. Fiber optic cables can also connect them to their control office in S5 or S1, so they can follow the status of their satellites in real time and make any necessary decisions. A launch table is a real factory. It is as complex as the launch vehicle itself. It must provide everything necessary to the launcher so it can be autonomous. We use it to save the launcher's resources before liftoff, so it can leave the pad with a maximum of fuel and energy on board. The table duplicates a large part of the functions found on the launcher, but must be more resistant to be able to work for the next launch. The launcher, on the other hand, leaves the pad and disappears. You can say that one is almost the mirror image of the other, because the table's role is to provide assistance to all the launcher's needs. Ground crews have a lot to do and can sometimes work twice as much as the launch crews, because they work in the preparation before integration of the launcher, then after the launch as well, to revalidate all installations. We recheck everything systematically each time, and that takes a lot of work. Having 2 launch tables for Ariane 5 is a tremendous advantage for us in terms of flexibility. 2 tables let us prepare one launcher while we have another one on the pad. With 2 tables, we can double our annual launch rhythm. For customers, this means more flexibility and availability.
The main differences between the Ariane 4 and Ariane 5 launch tables come from the different philosophies adopted in their conception. On Ariane 4, we wanted a minimum of mobile installations because it was so complex. Ariane 5, on the other hand, uses solid boosters which are somewhat hazardous, so the computer bays had to be fixed to springs to protect them from vibrations. We also opted for a mobile infrastructure which protects everything. This also gives us a big advantage in terms of flexibility, since the only connections you as a customer need to make are those when you arrive in the integration zones. None is needed for installation between the table and the launcher. With Ariane 4, once the launcher's on the table and has been checked out, it's already been in the launch zone 2 weeks. The transfer of Ariane 5 is done in 1 day.
Right, well, although that wasn't about the environment, it was relevant because it talked about the launch table and how it's used to contain the launcher before launch.
Yeah, so Mike, just to remind that we're still awaiting the DDO calling for resumption of the operations and start the synchronous sequence. So as when the launch base will give their go-ahead, then the DDO will start the launch the synchronized sequence.
And in the meantime, we are at 12 minutes. And well, let's go back to what we were talking about, the integration of the launcher. It had arrived and it's been taken to the 58-meter tall launcher integration building. That's where all the major components of the launcher are put together.
Well, everything except the upper part. What we call the upper part is the fairing, cylinder, and adapters and satellites.
So that takes place somewhere else in the final assembly building called the BAF.
The final assembly building is, as it's named after the nature of the operations that are performed there, and especially the integration of the satellites. The lower satellite, which is put directly on top of the VEB, the Vehicle Equipment Bay, and the upper satellite, which is mounted on top of the cylinder structure and then encapsulated and closed inside the fairing. And the whole assembly, fairing plus the satellite plus the cylinder, is put on top of the launcher, enveloping the lower satellite. Everything is, of course, assembled and all the electrical connections are made, enabling the satellites to have communication with their computer-based systems.
Right, and before they actually get there, the satellites are in their own facility, which I think is called the S5 building.
Yes, the S5 building is equipped with clean rooms, which allow two major things. Is first the preparation of the satellite when it arrives in French Guiana, so checking that everything is fine and okay with the concerning all the systems, the subsystems, propellant. Now we are green again.
And the
À tous de 2DO. Retour au vert de l'ensemble de lancement. Attention pour la reprise de la chronologie. Top, reprise de la chronologie.
So the countdown is progressing again.
De la séquence finale lanceur. Le nouveau H0 est 22h, 32 minutes, 50 secondes en temps universel.
Okay, and then there we are again.
Progressing once more. So while we're progressing through the countdown, perhaps we can continue our construction of an Ariane 5. So when the satellites have been processed in their building and the engineers have checked them out and they're ready to be put onto the launcher, they have to be transferred. Are they specially protected because they needed...
Yes, of course. So inside the S5 building, they're not only prepared and checked, but also fueled. And the communication between the preparation clean rooms and the fueling rooms doesn't need any handling system or any transportation system. They're big corridors which link all these rooms together, and the satellite is smoothly pushed on air cushions, air pads, from one room to another. Then the satellite is put into a special container, which is, of course, has cleanliness control and all contamination control, which allow the satellite to be transferred by truck on a trailer from the S5 building to the final assembly building.
Right, so everything scrupulously controlled from air conditioning to being in absolutely environmentally controlled conditions. So, About a day before the launcher and its payloads are transferred to the launch zone. We're going to see a rollout film later, but there's an enormous mass to transfer, isn't there, including the launcher, payload, and table.
Yes, indeed. The launch table itself is something over 800 tons.
And then on top of that, the over 800 tons of launcher. So it's a very big, heavy structure. So over to the launch zone, which is 2.8 kilometers from anywhere else.
2.6 kilometers from the final assembly building.
Right. So that's where the fueling takes place.
Well, the cryogenic fueling of the launch vehicle.
Yeah.
Yes.
Yeah. And it's where, hydrogen and oxygen and helium needed for the launcher. Whereabouts are they manufactured?
Well, the hydrogen and oxygen and nitrogen are manufactured here in Kourou. So there are two plants. There is one plant run by Air Liquide, who is in charge of the cryogenic supply for Ariane. And so they produce the nitrogen and oxygen at the same time with one plant, and the hydrogen is also produced here. So the helium comes from France or the United States by truck, and we get liquid helium here, and we transform it into gaseous helium for the needs of the launch vehicle. Just mentioning that we also have a capacity of liquid helium aboard the launcher.
Yes, that's interesting. Why do we use helium?
Well, helium is used for several uses. It's first an inert gas, so very useful to manipulate the oxygen and hydrogen with this gas. And it's also the only gas that can pressurize liquid hydrogen, because it becomes liquid at 4 degrees Kelvin. That is something like minus 269 degrees Celsius at atmospheric pressure. Whereas the hydrogen is liquid at 20 degrees Kelvin. So if we had nitrogen, for instance, we could not pressurize the hydrogen with nitrogen, which is liquid at 77 degrees Kelvin.
Right. So I hope you all understood that physics lesson. So, okay. The propellant fuel for the passenger satellites is normally hydrazine. Where is that made?
Well, there are several systems, propulsion systems for the satellites. Some are with only one propellant, and some are bipropellant. So you also have oxidizer and fuel, like nitrogen, tetroxide, and all this sort of propellants. So there are...
Attention pour H-7 minutes.
That's the deal calls for the H-7 minute step.
H-7 minutes.
So this is one of the main steps of the synchronous sequence.
Right, which we're now into. And things are progressing to plan at the moment. And those who may have just joined us late, this is an Ariane 5 ECA launch of Hotbird 7A and Spainsat. So let's go back to look at the launch zone facilities a little more closely. There's a concrete foundation on which the launch pad is mounted, and the launcher tower and 3 flame trenches. But before we come to that, we are going to have a presentation by 3 Arianespace operational team members.
Tonight's Ariane launch, the first of 2006, will use an Ariane 5 ECA to put in orbit Spainsat and Hotbird 7A. Spainsat in the upper position was built by Space Systems Loral for Hisdesat, located in Madrid, Spain. The primary mission of Spainsat will be to provide X-band service to the Spanish Ministry of Defense.
Spainsat is positioned at 30 degrees west above the Atlantic, covering an area from Spain to North America. This satellite has a launch mass of about 3,700 kilos, and after deploying with 2 solar panels, its span is roughly 31 meters. Its lifetime is 15 years.
Hotbird 7A, built by Alcatel Alenia Space for Eutelsat, will be located at 13 degrees west and provide television and radio service throughout the coverage area.
Hotbird 7A has a mass of 4,100 kilos, and after deploying the solar panels has a span of roughly 37 meters. Its lifetime is 15 years. It carries onboard 38 Ku band transponders. For this flight, an Ariane 5 ECA is used. The total performance required for this mission is 8.5 tons. The launcher will weigh over 780 tons, and the thrust will be about 1,200 tons. Therefore, this mission is special because of its 17-meter-long fairing.
Instead of the nominal 7 degrees inclination, we will improve that to 5 degrees, which in the end will provide a longer life for the two satellites.
So the combined payload of the two satellites is a massive 8.9 tons tonight. That's the weight of a medium-sized truck. The combined mass of the two satellites is 7.8 tons. So what accounts for the difference in the mass, Alex?
Well, the difference is the mass of the cylinder structure, which is about 500 kilo, and the mass of the two adapters for the satellites, 300 kilograms.
Right, and we are now going to show the CDL nerve center, which is about 3 kilometers from the launch. What are they doing so close
to
it?
This is the Arianespace launch team who is in charge of all the operations on the launch vehicle. So they're very, as you said, very close to the launch pad, between 4 and 5 kilometers inside the concrete shelter. And they are here in charge of, they can control, check, and operate all the systems and subsystems of the launch vehicle, electrical fluids, and also all the ground installation system.
Right, so you're now watching the launcher, and all is green. We're progressing towards liftoff. What are the important weather conditions for a launch?
Yes, of course, the weather conditions are very important parameters in the launch decision. And we have mainly the winds, the strength and velocity of the winds, and the risk of storm, of lightning. And for the winds, we also have a criteria, which is the strength and velocity of the winds at high altitude.
Right. So, as you can see, talking about the weather, when the rollout happened last Wednesday, the weather was okay. It was slightly cloudy, but the weather was fine. And it looks a very specialized job to drive such a truck as this, to carry it out.
Well, yes, indeed. So this table weighs, as I said, about 800 tons plus the weight, the mass of the launch vehicle. It's towed by a truck at a speed of 3 to 4 kilometers per hour, which represents for all the operations necessary to make the rollout, 45 minutes ride for over 6 hours operations.
So not the sort of job you get with a normal driver's license?
Not really.
So, back in the Jupiter Control Center, where
you can see Michael Clary, the Deputy Pilot Manager, and we just saw Luca Kekio, the Pilot Manager for Eutelsat. Michael Clary is for
right.
Spainsat.
So, you've been here many times before, so what's it feel like?
Well, feel like it's the first time every time.
Yes, and now we're showing the cryogenic arms. They're used to fuel the upper stage, and what happens to them at liftoff?
Well, as you said, they support the fueling lines for cryogenics, so LH2 and LOX, oxygen and hydrogen, and then the arms will be moved backwards, and then allowing the launch vehicle to lift off.
Right, okay. And
approximately 7 seconds before the H0.
Tous de DDO, attention pour moins 1 minute.
Right, you're hearing us coming up to the final minute.
Yes.
And the DDO will say...
H moins 1 minute.
Right, you're watching live from Kourou. Launch of Spainsat and Hotbird 7A. And we're coming up to the launch. And what happens at H0?
H0, the ignition sequence of the Vulcan 2 starts, and then during 7 seconds, a complete checkout of the engine main parameters will be performed. If all parameters are correct, then the onboard computer will allow the ignition of the solid boosters, which means liftoff.
Right, and which we are now less than 30 seconds away from. People are leaving Jupiter to go onto the balconies to watch. And we will leave you with the DDO for the final countdown, and we'll be back after liftoff. Enjoy the launch, everyone.
À tour de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage des EAP, décollage.
Wow, what a fantastic launch.
Tous les paramètres bord sont nominaux.
So we've heard everything is okay. 780 tons of launch vehicle and payload soaring into the night sky over Kourou. The Vulcan engine and the two solid boosters are still lighting the sky, and Ariane's already gone supersonic. The noise has reached us here in the Jupiter Control Center. And with the power, over 20 jumbo jets going at full throttle in the same part of the sky, you can just imagine the noise. Even the ground is shaking here. And you heard the DDO say everything on board Ariane is fine. And we're now into the first 4 flight phases.
Tous les paramètres sont normaux.
Right, what's to follow, Alex?
Yes, 4 phases. So solid boosters, main cryogenic stage, and upper cryogenic stage thrust phases, followed by the final ballistic phase without thrust before release of the satellites. So the DDO just said that everything's normal aboard launch vehicle.
So have a look at the left-hand side of the screen, and you can see a curve. So what's that telling us?
So this curve is the trajectory profile, which is the result of the flight prediction computation. So the spot on the curve represents the real-time trajectory data of the launcher. And as you can see, the real flight matches exactly the flight prediction. Below the curve, you can also follow the real-time altitude and velocity.
And you can see it's heading towards a spot which marks the separation of the solid boosters.
Yes, so right now we are about 65 kilometers altitude.
And going fast.
And going very fast.
Séparation des EAP.
So we've heard from the DDO that the solid boosters have separated. What happens to them now?
Well, they will fall down into the Atlantic Ocean. And this time we will not make any recovery operation. So they will fall and sink down into the ocean.
Right, okay. And we're now into the second powered phase of flight. And we see that the velocity and altitude are increasing.
La trajectoire est normale.
And as you hear, DDO
everything's normal.
Everything's normal.
About 100 kilometers and 2.1 kilometers per second.
Heading to the east.
Heading to the east.
So how does the launcher follow its predicted trajectory, Alex?
Well, the onboard computer software contains all the data of the trajectory that will eventually put the satellites on their respective orbits. During the flight,
Langage de la coiffe.
the computer just...
Right, so we've just turned...
Fairing separated.
Fairing
so
separated.
the computer, which is located in the vehicle equipment bay, collects all the data from the flight, compares them to the software prediction, and if needed, decides
Tous les paramètres sont normaux.
which corrections must be undertaken.
Right, so we keep hearing, very good, that the all parameters are normal, and you can see velocity and altitude increasing.
So for the onboard computer, the only obsession of this equipment is to reach the correct orbit.
Right.
La trajectoire est normale.
And again, we are hearing fine, everything is fine on board, and the computer is, as you say, it stays on board and does its job until the end of the mission.
Yes, and the fairing has also done its job.
Indeed, and is now falling into the ocean.
Into the ocean, so about 82 kilometers altitude, 1.7 kilometers per second.
We'll keep you updated after a few words from Jean-Pierre Ballet, the Arianespace Operations Manager on launches, on the launcher campaign.
This Ariane campaign started on January 3rd in the Launch Vehicle Integration Building. As usual, all elements have arrived by ship at the Kourou harbor. The first stage was erected on the first day. The day after, the two solid strap-on boosters were brought from their storage building, assembled and checked. On January 12th, the upper stage was hoisted and mated. The next day, the vehicle equipment bay was installed. Then, all verification tests were run in this building. On February 4th, Ariane was rolled to the final assembly building, where the next major steps were run: assembly of our two-passenger satellite, dual launch structure, and the fairing. The rollout to the pad took place yesterday, and everything is now ready for the countdown.
Well, as you heard, there's a considerable amount of preparation that goes on before a launch.
Yes, we've been talking about the different operations in the integration building and the final assembly building. This represents about 16 days in the integration building and 11 days in the final assembly building before the H0. The satellites themselves, as they are prepared in the S5 clean room facilities, well, the average time of preparation is here 4 to 5 weeks campaign.
So there's a lot of work goes on before we get to this magic day of launch. Now you're watching the launch of Spainsat and Hotbird 7A, and all is proceeding to plan, as you've heard from the DDO. Altitude and velocity. Thank you, Mr. DDO, confirming that. Altitude and velocity increasing normally. And we are looking at those values on the screen, and we are a velocity of 4.2223 km per second and 160.7 kilometers high. We'll be back after an overview of the satellite campaign by Philippe Rollin, Arianespace Mission Director.
On the fairing of the satellite, which is to be launched tonight, you can see our two customers' logos, Hisdesat and Eutelsat. These two companies will implement and operate several years the two satellites, Hotbird 7A and Spainsat, to be launched tonight. Hotbird 7A arrived in French Guiana on the 19th of January, and after 3 to 4 weeks of preparation, the satellite was moved to a specific building to be filled and assembled on the launcher on D-5, that is Saturday the 11th of February. As to the Spainsat satellite, it arrived a bit later, on January the 24th, and after fueling operations, it was hoisted on the launcher on Monday the 13th of February.
Is again confirming what was being said before and what Alex was emphasizing. A lot of work goes on. Tonight we have a launch window of 1 hour and 7 minutes. Why is it of a specific duration?
No, the launch window is driven by the constraints of the two satellites. After separation, a satellite must have a
Acquisition de la télémesure par la station de Natal au Brésil.
So
Right.
the Natal Brazilian station gets the telemetry from the launch vehicle. That's good news.
So it's good news, it's passing on. So good.
So after separation, a satellite must have a predefined orientation so that its navigation sensors are correctly oriented towards the Sun, the Earth, and other celestial bodies, while meeting the other requirements like the orientation of the sun illumination to control the thermal effects. This orientation varies over time, which explains the need for a launch window. It's worth mentioning that the launch vehicle itself has no constraint coming from its system, so the launcher can lift off at any time.
Right, so a lot of calculations have to go into establishing the launch window.
Fin de
for the
propulsion
passenger.
de l'EPC. Séparation premier étage.
So we've had separation of the first stage, and when it's done its job, Alex, again, what happens to it?
Allumage moteur deuxième étage.
So
And very quickly,
ignition of upper stage.
Fin de l'acquisition télémesure normale à Galio.
We lose Galileo, but we still have Natal. So,
we'll have them tell.
yes, back to your question, Mike.
Tous les paramètres bord sont normaux.
The main cryogenic stage will fall down into the Atlantic Ocean, west from the African coast.
Right, again, so aircraft and ship movements in the area. have to be restricted.
All the zones are, of course, submitted to the International Danger Notices regulations for both airplane and maritime traffic. Well, in fact, the whole trajectory is defined so as to avoid as far as possible that the launcher flies over regions with high density of population. This is what we call the flight safety.
All right, yeah. Now, is this the heaviest payload we've carried so far?
No, the heaviest payload ever carried by Ariane 5 was Spaceway 2, 6.1 ton, on Flight 167 last November. We can mention that this dual launch represented a total of 9.3 tons of performance, heaviest payload mass ever put in GTO orbit.
To carry these payloads, we've got a very strong adapter, and we'll be back after a description of it by Marc Roy, who is the Ariane 5 upper stage project manager.
Here we are, in front of the final assembly building. Carrying a satellite on the launcher requires a structure called a payload adapter. These systems link mechanically and electrically the satellite to the launcher. They also allow the separation and the motion of the satellite as soon as the injection point is reached on the targeted orbit. The launcher's structures have been designed thanks to the state-of-the-art technologies perfectly controlled by EADS-CASA. They build payload adapters and also the vehicle equipment bay, the VAB, as well as the interstage skirts, thanks to a fully automated new generation carbon fiber coating process. Thanks to these new technologies, mass saving and above all improved mechanical performance of the various launcher structures were achieved. Some adapters, as the Type 1194H, have specific features. They are fitted with a thermal clamp band in order to connect the satellite to the structure. First of all, the clamp band is heated in order to increase its length before being bolted and locked. The tension required to maintain the satellite on the ground and in flight is generated by the decrease of its length while it naturally cools down. They also have a carbon flange linking to the launcher. This was made possible thanks to the automated coating process. These EADS-CASA adapters weigh 150 kilos and are capable of orbiting satellites of over 6 tons. With these structures, Arianespace offers a full compatible range of various types of telecommunication and scientific satellite platforms. By the end of 2006, new adapters fitted with high-performance separation systems will have been developed in close collaboration with EADS-CASA and Saab Ericsson Space. In such framework, EADS-CASA are working on a new clamp band system generated limited shocks, thus easier to operate. The outcome of the research will enable Arianespace to have fully interchangeable adapters compatible with Ariane, Soyuz and Vega, allowing an optimum launch flexibility.
So we're now into the second half of the mission, and all is running well. The upper stage is running. Can you tell us a little more about it, Alex?
Well, I will first tell you that we still have about 12 minutes thrust phase for this upper stage. Everything is going well up to now. And this upper stage, yes, is equipped with the HF7B.
Perte normale de l'acquisition de la télémesure pendant environ 80 secondes.
Okay, so this is interesting. We shall lose telemetry during about 80 seconds. So you won't see the parameters vary on the screen. This is due to the, well, depending on the trajectories, we might have a loss of, well, a gap, in
Acquisition de la télémesure par la station d'Ascension.
In the acquisition.
In Ascension Island.
And this was the case at the moment.
Right, but we now have a presentation from Mr. Giuliano Beretta, DG of Eutelsat.
The relation between Arianespace and Eutelsat is a very long story that starts from the beginning of the Eutelsat putting satellites into orbit. We have until now 21 contracts for launchers of satellite with Arianespace, and despite the accident of 2002, we give full confidence in this company because the satellite that we substitute, the Hotbird 7 that we lost, will be launched again tonight with Arianespace, which is the Hotbird 7A. So we think that Arianespace is an excellent system. I cannot say that it's a relation privilegée because Eutelsat is a private company, and it only chooses the best and the one that is able to give the performance. So it's more merit for Arianespace being able to provide so many launchers to Eutelsat.
So the launch of Spainsat and Hotbird 7A are proceeding to schedule.
In the meantime, we've recovered the telemetry from the launch vehicle.
Right, so...
And then we know that everything's fine. Everything's okay aboard the launcher.
That means that it's being tracked by Ascension Island, is that right? Yep, which is in the Atlantic. So, as you can see from the curve, Ariane is continuing its ascent and velocity is increasing. And there are a network of these ground stations around the world that relay telemetry to Kourou.
Yes, a network of ground stations from Brazil to East Africa and Australia, so as to be able to receive the telemetry all along the trajectory from west to east. Trajectory, but also the altitude of the attitude of the launcher are constrained.
Okay, well, we'll be right back after a short film on Eutelsat.
Eutelsat, one of the world's leading satellite operators, launches Hotbird 7A, a new star for Europe's premium video neighborhood. Joining Eutelsat's constellation at 13 degrees east, Hotbird 7A will reinforce Europe's leading location for satellite television and radio broadcasting. Delivering over 850 TV channels, of which nearly 360 are free-to-air and more than 560 radio stations, the Hotbird satellites reach an audience of over 130 million satellite and cable homes in Europe, North Africa and the Middle East. In addition to broadcasting standard digital channels, the new satellite will usher in a new era in home entertainment by delivering razor-sharp HD TV images to television homes. Built for Eutelsat by Alcatel Arianespace, Hotbird 7A will replace Hotbird 1, a satellite that has provided more than a decade of stellar service at 13 degrees east. It will also accommodate new digital channels and provide backup capacity at its prime video neighborhood. The addition of Hotbird 7A will also ensure that the 13 degrees east constellation provides broadcasters with the highest levels of in-orbit security and consolidates Eutelsat's fleet as one of the youngest in the fixed satellite services sector. Hotbird 7A from Eutelsat, pioneering a new generation of satellites at 13 degrees east.
Well, that showed us very clearly how technology is rapidly progressing in the world of TV and internet transmission, and Eutelsat is one of our loyal customers, very loyal customers. Now, we stopped you in talking about the ground stations.
Yes, well, just to add that the trajectory is constrained by a certain number of criteria, and among them the orientation of the antenna, so that we can at any time get the telemetry from the launch vehicle.
Right, and as we heard from the DDO, everything is progressing normally.
Everything is progressing normally. We still have about 6 minutes, 30 seconds of propulsion for the upper stage.
And altitude 184 and 185. Right, the next station in West Africa.
Libreville got the telemetry from the launch vehicle.
Right, so everything proceeding to plan.
As planned, yes.
Fin de poursuite normale par la station d'ascension.
So Ascension station has finished its work.
Right, well, that was a very short spell it had to do, but obviously extremely important. And we'll be back after a short statement from Mrs. Petra Mateos Aparicio, President of the Board of Hisdesat.
As president of Hisdesat, it's a great honor for me to be here for the second year in a row at the European Space Agency's base in Kourou, this time for the launching of the Spainsat satellite. Last year we gathered here to witness the successful launch of the X-Star, the first of the two satellites that make up the Spanish Defense and Governmental Communications Program operated by Hisdesat. Once again, we have placed our trust in the Arianespace launch vehicle Ariane 5 ECA. With the Spainsat in orbit, ECA becomes the world's first provider of secure communication services in X and K band, with coverage reaching 2/3 of the Earth's surface, from west of Denver to Singapore. The goal of the program is to offer efficient communication solutions for defense, foreign policy and security, which includes peace and humanitarian aid missions. With our American partner Lowell Space, we also offer strategic communication services for allied and friendly countries. The launching of Spainsat is an important step forward in high strategic value communications. The production of this new generation of satellites has also meant the active participation of a Spain's aerospace industry with returns of high technological value.
So Hisdesat, another very important client of Arianespace. Everything is progressing to plan for Ariane 5 ECA, the launch of Spainsat and Hotbird 7A. We're coming up soon to the phase which is called ballistic. What does that mean exactly?
Well, the word ballistic is related to the characteristics of the motion of objects moving without any acceleration that is provided by an engine thrust.
Right, and we're now going to show you a short film on Hisdesat.
We're too long.
Hisdesat is a Spanish company specialized in the acquisition, operation and commercialization of satellite systems. It provides strategic and communication services to government clients, international organizations and allied and friendly countries for both civil and military applications. Hisdesat is the operator of the Spanish Ministry of Defense for the second generation of its satellite communication systems until the year 2020. Hisdesat shareholders have 40 years' experience in services and operations with telecommunication satellites. The new government communications system managed by Hisdesat is based on 2 satellites. XStar, in partnership with the American company Lowell Space and Communications, and Spainsat, an entirely Spanish satellite. This communication system has a ground control segment for the satellites in orbit, composed of control centers and monitoring stations. The most remarkable part of the Spainsat satellite is the IRMA antenna, which was entirely developed in Spain and which serves to protect communications from interference, intentional or otherwise. In addition, other units of the satellite were developed and manufactured by the Spanish industry. With the launch of Spainsat, Hisdesat begins the operating phase of the new government satellite communications program, increasing and improving communications and giving them greater flexibility and security. This new system will triple the current capacity of government communication services. Hisdesat, secured communications.
A clear indication on how technology is being used to aid the security and well-being of millions of citizens. Arianespace is expanding its operation here in Kourou, Alex, isn't it?
Sorry to interrupt, just to say Malindi gets telemetry from the launch vehicle.
Right, so all is progressing well. So, yeah, what's the expansion that's going on here in Kourou?
Well, the expansion is here in Kourou we have the possibility to launch there from north to east, and Arianespace also wants to better match the need of all customers for all kinds of satellites and orbits. That's offering a full range of launch possibilities thanks to Soyuz, Ariane and Vega.
So as you've heard,
everything is normal. So then this will provide the customers with the most modern and fully operative satellites processing facilities, any mass at any time.
So a very flexible family of launchers from Kourou in the future. You're watching the launch of Spainsat and Hotbird 7A, and we're now going up the curve of the predicted trajectory. Speed's increasing.
We're approaching the cutoff of the upper cryogenic engine.
Right. Once that has happened, has it used all its fuel?
No, a certain amount of fuel, what we call the flight reserve, will remain inside the cryogenic tanks of the main stage and the upper stage. In fact, the success of the mission is characterized by a probability of success which must, as planned, the cutoff of the cryogenic engine of the upper stage.
Right, but as you said, not it's running out of fuel.
Yes, so it's a matter of success of mission and the probability of success of 99%.
Right, and we now will be having a presentation by Miguel Ángel Garjo Primo, the Satellite Mission Director of Spainsat.
After the separation of the Spainsat satellite, a series of procedures will be carried out in order to put the satellites from its geostationary transfer orbit to its final orbit at an altitude of 36,000 kilometers and longitude of 30 degrees west. The satellite will have two control centers, the main one located in the Arganda station and the secondary in Maspalomas, as well as two redundant tracking stations also located in Maspalomas and Arganda, in order to ensure optimum security. The ascent phase to the final orbit will last about 10 days and will include 4 main procedures related to the ascent of the satellite to its apogee. I would like to take this opportunity to congratulate Space Systems Rural, Arianespace, and all the Spanish companies which took part in the project. I'd like to thank the ECA shareholders for their understanding and support throughout the project, as well as our main customer, the Ministry of Defense. Without their participation, this project would have been impossible.
Okay, well, let's go back to what we were talking to before the film, Alex.
Yes, so to achieve this goal of mission probability, the fuel budget must cover all the uncertainties of the propulsion characteristics, the measurement of the launcher's mass, the perturbations on trajectory during the atmospheric phase, etc., which are all assessed in the flight prediction. In other terms, the flight reserve covers the uncertainties between the predicted flight and the real flight.
Right. So as the DDO has just mentioned, so we have a satellite which is separated, the first satellite, and although that has now satisfied one customer, they are being tactful and they realize that there's still more time to go for Eutelsat. What is actually going on up there now in Ariane in the closing phases of the mission, Alex?
Well, the launcher is now composed of the upper stage, the vehicle equipment bay, the CILDA, and the lower passenger. The CILDA is, as said, the inner cabin, mainly cylindrical structure which supports on top the upper payload and envelopes the lower payload Hotbird 7A. So the launcher will be oriented for the CILDA separation, which will further allow the lower satellite to be separated from the launcher. This sequence is controlled by means of thrusters, which are positioned on the upper stage skirt.
Right, so still quite a lot of important things to happen before the mission is finished. But we're going to have a few words now from Martin G., the Satellite Mission Director of Eutelsat.
So following separation from the launch vehicle, the Hotbird 7A satellite will be acquired by the Malindi tracking station. This is in Kenya and is part of a global network of tracking stations which allow us to perform telecommand, telemetry and ranging on the spacecraft. This is all performed via our control centre in Rambouillet, just southwest of Paris. The first phases of these operations concern the partial deployment of the solar array to provide additional electrical power to the spacecraft, then 4 apogee firings during which the satellite is circularized and the inclination removed. This is then completed by the full solar array deployment and the antenna deployments and the acquisition of the Earth within the normal mode of operation of the spacecraft. The spacecraft is now at 9.8 degrees east, where the in-orbit test program is performed to characterize the payload performances and the onboard subsystems. On completion of this test program, the satellite is moved from 9.8 to 13 degrees east, where it will start operations with the rest of the Eutelsat Hotbird constellation before the end of March.
Okay, so Hotbird 7A due to be separated in about 2 minutes. Before that happens, the cylinder cover has to be removed to make way for the separation. So how's that done, Alex?
Well, we've been talking of the spacecraft separation, so the cylinder will be separated in a similar way. The bottom part of the cylinder pyrotechnical cord will operate the perfect cut, while at the same time several springs evenly spaced on the inner skin of the cylinder will move the cylinder cover away from the launcher.
So it's a matter of pyrotechnics and springs, and remembering it's over a 4-ton vehicle, so but to lift it out, what's the springs? Very powerful?
Well, we have different sets of springs depending on the motion that we want to communicate to the satellite according to its mass and inertial characteristics.
Right, so we're approaching the final stages. The velocity 8.5. Cylinder, there it goes.
So the cylinder, as you can see on the screen, the cylinder is now separated from the launch vehicle, so the lower satellite is ready for release.
And it's ready and in the open. And we're awaiting final separation.
But after separation of the upper spacecraft, the launcher's mission is not finished, and after separation of the lower spacecraft is not finished as well. So the upper stage and the vehicle equipment bay will be oriented to avoid any collision with the spacecraft, and then the propellant tanks will be depressurized. This is what we call the passivation phase. So that there is no residual risk of explosion of the hydrogen and oxygen tanks in order to avoid the dispersion of thousands of debris on orbit around the Earth.
Yes, and also, of course, the two satellites have to do their maneuvering over the next days. And
well, they will do their own operating process, yes, to deploy their solar panels, then check all their subsystems and systems before they operate their engines to get there on their final orbit, circular orbit around the Earth.
Right. So we're awaiting the time. And there we have separation of the second satellite. And we have now delivered the two satellites safely to geostationary transfer orbit. Ariane 5 ECA heavy lift launcher, another success. And you can see that everyone in Jupiter Control Center is delighted with that result. And with two relieved and very delighted customers, you can see on the screen. I expect that celebrations are also going on around in Europe and the USA and elsewhere.
And especially here in Korea, Mike.
Very much so, yes. And now perhaps we can go to the competition question. That Eutelsat are a very loyal customer, and we launched their Hotbird 1 some years ago. And do we know when it was? And who was launched with it?
Well, I'm afraid I don't remember.
Do you know, we've already got people phoning in. They're very hot off the mark. And it was 15 years ago, on the 28th of March, 1995, on a 44 LP. Co-passenger Brazilsat B2. I thought with your experience, you remember, you were probably here.
Well, I was there, but I really don't remember this. I'm sorry, Mike.
Well,
I'm not the winner tonight.
Well, that's a shame, because the prize is a really good one. You never guess what it is. It's you get to do the commentary for the next launch.
You'll be welcome anyway.
Right, so we had to wait for a bit, but it's worth it. Everyone is very happy, and we have two successful satellites now.
That's a very good conclusion to all these days of uncertainties.
Absolutely, yes. And we shall be showing you a replay of that fantastic launch soon before the speeches come. Can't really wait to see it. It was so impressive. But as you can see, all the staff in Jupiter are absolutely delighted. Handshakes all round, big smiles, relief on everyone's faces.
It's really the joy that appears on their faces.
Oh yes, and this is the launch again. Wasn't that fantastic? I've heard from people who've been at Tucson that the vibration you feel through the feet.
Yes, it's 4 kilometers away from the launch pad. So yeah. It's the closest point of, for a viewing site, the closest point from which you can see the launch.
That's amazing.
It's a really impressive show.
Yeah. You first see the light, and then feel the shaking through the ground, and then the sound hits you. Here it is again. That is a powerful baby, isn't it?
So that was the first launch of the year?
Yes. And
that's a good start for 2006.
Absolutely. So everyone is looking forward to the next, I expect, now.
I think not only the customers, but also the manufacturers of the 2 satellites, Alcatel Arianespace for the Hotbird 7A and Space Systems L'Oréal for Spainsat.
Yes, and here we have Mr. Legal.
De le voir, les 2 satellites Spainsat et Hotbird de 7A.
As you can see, 2 satellites, Spainsat and Hotbird 7A, have reached geostationary transfer orbit, and I'm very happy to share the success with you. I would first like to thank our 2 customers, Hisdesat and Eutelsat. Spainsat is a particularly innovative and emblematic satellite for Spain, and I would like to say to the president of Hisdesat, Mrs. Petra Mateos, how proud we are to be associated with a governmental project such of dimension. Moreover, I would like to take this occasion to recall that Spainsat is the 25th military payload that was launched by Ariane, which emphasizes once again the role of Arianespace in this domain.
Je veux rappeler à cette occasion que Spainsat est le 25e satellite militaire lancé par Ariane, ce qui réaffirme le rôle fondamental joué par Arianespace dans ce domaine.
Concerning Hotbird 7A, this was the 20th satellite launched by Arianespace for Eutelsat. This privileged relationship between our 2 companies is particularly commendable, and I am extremely happy to see that it is confirmed once again. I would therefore like to thank Mr. Beretta and his shareholders for the confidence that they have shown in us. I would like to point out that this launch is the first of a kind that took place in the frame of a new industrial organization which was set up in 2003. The organization reinforces the role of Arianespace, who is now in charge of marketing, managing, and use of European launch vehicles, among which first comes Ariane, which is now manufactured under the total control of EADS-ST. So I want to congratulate all the teams in Europe and France and Guyana who have made their very best efforts to prepare this launch. The campaign was long, but a success. Finally, I express my sincere thanks to the European Space Agency member states for their valuable support, and I want to underline the major role played by France in these programs, thanks to CNES, the French Space Agency.
Aux récentes déclarations de Monsieur le Président de la République, qui a indiqué avoir décidé de donner une préférence européenne pour le lancement des satellites gouvernementaux français et qui a invité les partenaires de la France à faire le même choix. Voilà ce que je voulais vous dire après ce tir parfait. Et sans plus tarder, je passe la parole à nos clients. Tout d'abord,
I now leave the floor to our clients, Hisdesat and Eutelsat.
Beretta depuis Paris.
Merci, thank you very much, Yaniv. Ladies and gentlemen, let me start my speech saying thank you all of them for staying here, seeing the launch. And I apologize, but I will change to Spanish because of my people in Spanish, okay, in Spain. En primer lugar, quiero expresar la enorme satisfacción.
I would first like to express the most intense satisfaction following the injection into orbit of a satellite Spainsat for the company Hisdesat Servicios Estratégicos and for myself as the CEO of this company. This launch is a reward for all the work done during many years by the personnel of Hisdesat, but also by the companies and organizations that have contributed to our project. The success that we just witnessed is the outcome of the efforts that were made by all of them. On the way to research and development, continuity and perseverance sooner or later bring success. This especially applies to the space programs, from the conception to the follow-up of on-orbit operations. The lifetime of Spainsat is approximately 25 years. I would like to congratulate Arianespace for the magnificent launch we had. I would also like to congratulate all our co-passenger, Hotbird 7A, Eutelsat and Alcatel Arianespace. And of course, my sincere congratulations to our prime contractor, Space Systems L'Oréal. We have had some difficult years together, but above all, we have overcome the difficulties which have brought us to the ultimate point of this project, tonight's launch. With the launch of Spainsat, the new National Telecommunications Program is underway. With Spainsat in orbit, we can satisfy the needs for military telecommunications as defined in the National Strategy for Defense and in the Strategic Plan up to 2020. A new generation of satellites was born, which will be operated by the Spanish company Hisdesat, in order to improve, widen and provide Spain with more flexibility and security in these telecommunications. Spain will then acquire an autonomy and a high-level response capacity in accordance with its current needs. The new system will bring a substantial increase of telecommunications capacities to the Ministry of Defense with respect to bandwidth, power, coverage and security by tripling the current capacity. It will respond to the needs associated with two types of mission: to guarantee security and without jamming, be it intentional or not, to the forces who are deployed on international peacekeeping duties and support after natural catastrophes. The commitment of Spain to take more responsibilities in the institutional organizations, NATO, United European Union, requires from us to be able to provide a great amount of governmental military telecommunications of high quality. These two satellites will provide a capacity in telecommunication covering the 2/3 of the planet, comprises technological innovations which provide a great flexibility to give an immediate response to the demands of governmental communication, like the anti-jamming IRMA antenna equipped with a great number of reconfigurable and interconnectable channels. Another element to be mentioned is the access to the control of the satellite thanks to a telecommand encrypted algorithm with very low level of vulnerability. In addition, the system can be interoperated with two terrestrial terminals in X-band, which allows compatibility between the systems of allied countries. Hisdesat and Xstar have 20 transponders of 72 MHz bandwidth and 100 watts of power, with a coverage from Denver to Singapore. I would like to point out that the great success of the European technology for free access to space, the commitment of the member states of the European Space Agency has been rewarded. It's worth mentioning the high level of technology brought by the Spanish space industry, and especially INTA, which is in charge of development, manufacturing and qualification of the launch vehicle upper part structures. Finally, I would like to congratulate the Spanish companies who have participated to this project. These companies have developed the ground antenna for command and control of the satellites in S and X band. Casa Espacio has developed the parabolic reflectors and sub-elements in X and K band. INTA, Casa, Crisa, Indra and Mir have developed the IRMA antenna, RIMSA has developed the antenna for command and control of the satellite in S-band, and GMV has developed the control center for the Spainsat satellite. In summary, most of the payload elements have been developed by Spanish companies. Concerning the operating and control process of Spainsat satellite, all these installations, which are located in Spain, will be operated by Hisdesat. Thank you all for your assistance.
Thank you very much.
Donc à présent, je pense que M. Beretta va nous parler depuis Paris.
Mr. Beretta will talk from Paris by telephone.
Well, while we're trying to get the link from Mr. Beretta, I'd be happy to thank Arianespace for such a tremendous launch, and congratulations on behalf of Eutelsat and our team, of course. The 21st launch of a Eutelsat satellite by Ariane, and a key step for Eutelsat in its renewal and expansion of our fleet. It's the first of a second generation of satellites for broadcasting satellites at 13 degrees. And Hotbird 7A has been designed to replace the Hotbird 1 satellite, and it will actually increase the capacity of a Hotbird capacity at 13 by a further 2 transponders. And we're looking forward to the redundancy at 13 being increased further by the Hotbird 8 launch, which will occur later this year. But this is the appropriate time and place to thank sincerely the Arianespace, CNES and CSG launch teams, as well as Alcatel-Alenia-Space's launch team in preparing the readiness for this launch and the satellite, and for the very hard work that's gone into it. And I want to thank our own launch team too, led by Martin G. and Philip Maton, you saw on the screen earlier, and all those who spent time working here over the past 7 or more weeks. Patience is rewarded, and rewarded in the best possible way, Mr. Legal, by success. And it's important to recall that our operations teams have been patient too in Paris, and working now intensively on the critical operations over the next 12 days to position the satellite ready for its testing and checkout, and to deliver the quality that our customers would expect. I can say we've already received the telemetry from the satellite, and the checkout is already in process, telecommanding and initial satellite health, and we expect to deploy partially the solar arrays on schedule in the next couple of hours. Once again, Mr. Legal, I'll be very brief, but my congratulations to Arianespace for such a perfect launch. We're already looking forward to the next launch being as good. And my congratulations too go to our co-passenger, Hisdesat. And we trust that the rest of the deployment activities for us both, for Hotbird 7A, to bring it into service during April will go as smoothly as tonight's operations. Thank you, Mr. Legal.
Bien, merci. Donc l'année commence, elle est loin d'être finie, puisque nous avons prévu de faire 5 ou 6 lancements d'Ariane 5 cette année. Donc on en a fait un, donc il en reste 4 ou 5 à faire. Et le prochain aura lieu mi-mai avec un satellite mexicain, SatMex 6, et un satellite thaïlandais.
We'll still have 4 to 5 launches to make this year.
Ariane 5
And the next
ECA
one will be mid-May for another Ariane 5 ECA.
Et vraiment désormais, je crois, le cheval de bataille, non plus de l'Europe spatiale, mais des opérateurs du monde entier. Merci et bonsoir.
So Ariane 5 is now the workhorse for the European space industry. And the next launch will point to orbit SatMex 6 and
Mesdames
take
et
up
messieurs, je
5.
vous invite à vous rendre sous le hall Jupiter pour partager une petite coupe bien méritée. J'en profite pour vous annoncer qu'il n'y aura pas de cocktail au Créolia ce soir et je vous souhaite une excellente soirée. Merci à toutes et à tous.
Mike. So Mike, we're now approaching the conclusion of tonight's launch, tonight's event.
Yes, and it's been a pleasure to be here with you, Alex. Your
Pleasure
expert
was from me,
technical
Mike.
support and answers to my many difficult questions. And as you heard Mr. Legel say, next launch is scheduled for mid-May, and we look forward to being with you again then. So, it's goodbye from me, Mike Phillips.
It's goodbye for me, Alex Madambassi, and Mike. Looking forward to welcoming you again in Peru for another bright good night.
Thank you. And,
tonight.
thank you, everyone out there, for being with us. Good night.
Goodbye, everybody. See you next time.